The ambient lighting design combines the decorative function of the lamps with the decoration and structure of the building by arranging lamps inside and outside the building, and use different light distribution and composition to meet the artistic requirements of the building. There are three main types of processing methods for indoor ambient lighting. The first mainly uses the artistic decoration of lamps. For example, using artistically treated sunlights, combining dark lamps and ceiling lamps with the ceiling to form various patterns, and using wall lamps to improve the brightness of some walls. The second uses a number of simple and uniform lamps arranged in a regular pattern. The third, architectural large-area lighting art processing. This is a form of lighting in which the light source is hidden in the building components and integrated with the components. It is divided into two categories. One is the light transmitting luminous ceiling, light beams, light bells, etc., and the other is the reflective light eaves, light niches, reflective false beams, etc. These two categories have common characteristics. The first, the luminous body is expanded from a scattered point light source to a light-emitting strip or light-emitting surface, which can obtain higher luminance while keeping the brightness of the light-emitting surface low. The second, good light diffusion, uniform illumination throughout the space, and soft light. The third, eliminates direct glare and reduces reflected glare. This is a comparison of surface brightness of light source of several lighting forms, from which it can be seen that the surface brightness of the light-emitting ceiling with different methods is quite different. Under the illumination conditions of 100 lux on the working surface, the surface brightness of the lamp using the diffuse transmission material in Fig A is the largest, which is equal to 5,000 to 10,000 a perctube. The surface brightness decreases sequentially from the light transmitting ceiling shown in Fig B, the reflective ceiling shown in Fig C, and the lightest type light emitting ceiling shown in Fig D. Among them, the brightness of Fig D is the smallest, only 10 to 100 a perctube. In order to reasonably distribute the brightness of the surface, the indoor space is generally divided into several areas, and different brightness treatments are given according to their use requirements. To highlight the visual center, make the visual center 5 to 10 times brighter than the adjacent surface. The effective area is regulated by lighting standards to avoid visual fatigue caused by excessive changes in brightness. The brightness of the ceiling area should not be large and should be concise and unified with the overall atmosphere of the room. The surrounding air should avoid the brightness exceeding the ceiling air and do not do too much decoration so as not to affect the focus, but it should not be lower than 34 candela per square meter. Otherwise, it will make people feel dim. Part of the interior needs to highlight the artistry of lighting, which can be in form of diffuse lighting, direct lighting, background lighting, wall flood lighting, etc., and can use light diffusion and concentration flickering color, etc. In addition, indoor environmental lighting design should consider meeting psychological needs. Although the main purpose of lighting is to make the viewing objects clearly visible, different lighting spaces give people different feelings, which can make a space appear spacious or narrow, make people feel relaxed, happy, or depressed, and even affect people's emotions and behaviors. Outdoor lighting includes urban functional lighting and nighttime landscape lighting. The latter refers to the nighttime landscape lighting of various outdoor activity spaces or scenes, excluding stadium, construction sites, road lighting, and outdoor security lighting. There are three types of building facade lighting: contour lighting, flood lighting, and translucent lighting, which can be used individually or in combination. Tone lighting is a lighting method that directly outlines the outline of a building or structure by using the dark night sky as the background. It is suitable for buildings with prominent contours, generally cold-castled fluorescent lamps, new lights, LED lights, general receiving lamps of 9 to 13 watt are used, and a ring cover is added. The lamp distance is 13 to 15 cm, and it is installed along the building contour. Floodlighting is used for buildings with large size and inconspicuous outline. It is not suitable for the case where the wall light reflection rate is less than 0.2. The illuminance depends on the importance of the building, the environment, and the effective characteristics of the surface. Generally, high-intensity gas discharge lamps are used. Translucent lighting is a lighting method that uses indoor light to transmit outward. At night, only need to turn on the lamps near the window and hang light-colored curtains. Light pollution refers to the negative impact of disturbed light or excessive light radiation on human health and human living environment. The light pollution of outdoor lighting mainly comes from urban landscape lighting and functional lighting such as building facade lighting, road lighting, square lighting, advertising lighting, sign lighting, stadium and parking lots. For example, the light directed to the sky increases the brightness of the sky and affects astronomical observations at night. Light directed to nearby areas interferes with the work and life of people in nearby buildings and affects traffic safety. Light pollution from outdoor lighting not only interferes with people's life and work, but also causes energy consumption, which is not conducive to environmental protection. Green lighting projects aim to save resources and protect the environment. It includes three complex subsystems: cleaner production of lighting equipment, green lighting, and pollution prevention and control of lighting equipment waste. The purpose is to make the lighting achieve high efficiency, energy saving, safety and comfort, and benefit to the environment. The specific contents include artificial lighting energy saving, natural lighting energy saving, management energy saving, pollution prevention, healthy lighting. To do this, it is necessary to prevent grid pollution, prevent overheating, prevent glare, prevent ultraviolet rays, and prevent light pollution. Lighting energy saving is evaluated by lighting power density value (LPD), and the lighting power density value should be no longer than the specified value. The factors of lighting energy saving is the energy saving of lighting design, that is, the most effective use of lighting electricity, and the condition of ensuring that the visual requirements of the operation are not reduced. Specific measures of lighting energy saving include: the first, adopt light source with high light efficiency and long life. The second, choose lamps with high efficiency, reasonable light distribution, and high quality accessories. The third, determine a reasonable standard value of illuminance according to the requirements of visual work. The fourth, choose the right light method. The fifth, use light-colored interior surface to ensure that the indoor surface reflectance meets the requirements. The sixth, control electricity consumption and measure separately. The seventh, subdivide the indoor lighting circuit and more switches, and set a single switch for the lamps near the window, which are automatically controlled. The eighth, outdoor lighting adopts automatic control. The ninth, use natural lighting during the day. The 10th, utilize new lighting technology. Think about it, how to achieve green and intelligent management in lighting management. Can the landscape lighting of ancient building and modern building adopt the same design method? What are the effects of natural lighting and artificial lighting on the indoor thermal environment?